in order for those sediments to become a rock, several things need to happen. The first thing is they need to be compacted, right? The particles need to be squished together so that they can then have some form of cementation or like something come into between the spaces of the sediments that hardens it up. Otherwise, it's just dirt, right? That's the difference between the rocks and the dirt. And this is called lithification. It's that process of going from sediments to a rock. It's lithification. So we've got compaction, which can either be physical, which is the physical squishing, or the chemical compaction, which is evaporation. That's how we end up with the halite. Cementation is the next step. That's where the cement fills in the pore spaces and holds it together. And we're going to look at how that works in just a second. So, like for example, sandstone. Here's the process. Sand is deposited, then more sand is deposited, more sand is deposited, so you have layer on layer on layer on layer, and over time, the stuff that's down on the bottom is going to be compacted by all of the mass on top of it, and then the chemicals that are in solution in the water are going to percolate down into the pore spaces, and some of the solution adheres to those grains, right? So like if you have calcite, calcium carbonate in solution will start to adhere to the grains of the rock or the grains of the sediments and eventually fill in and make that rock into a hard, make those sediments into a rock. And that's cementation. You know, there's all different kinds of cements that can be used. The common ones that we're going to look at are calcite. That's the ones that we test for. So if you're looking at limestone, you drop a little dropper of acid and you're going to get a fizz. You can get silica, which is, that's the hardest one that's formed from quartz. And iron oxide. This is where you get your red rocks, like you were talking about, Pam. The iron oxide is the cement in those sandstones. Chemical rock formation is pretty complex, but in general though, and it's not, you know, there's always exceptions, but in general, it's whenever water evaporates out of a solution, it's the salts and minerals that it leaves behind, like gypsum or halite. Can't think of any more. So example, water evaporating from a saltwater solution over and over eventually builds large thicknesses of salt, forming a bedded salt deposit like those that are formed during the Jurassic in the Gulf of Mexico. If y'all go to like old lakes, you can see like crusty things around the edges. A lot of times those are salt deposits around the edges of lakes. When the water evaporates, then the salts are left behind. Okay, if water is supersaturated with calcium carbonate, then limestone or travertine, which is a form of limestone, can actually precipitate out of the solution. So whenever there's so much calcite dissolved and the water starts to decrease, it leaves that calcium carbonate behind and travertine can form. So first the water flows through the air, then it absorbs some of the carbon dioxide and becomes carbonic acid, or the water contains some carbonic acid. It's a very weak acid. As it goes through the ground, goes into the limestone cracks, and it sits there. As it sits there, it dissolves the calcium carbonate, and we eventually end up with that karst topography. Karst means like it's holy, not holy like oh, but holy. You know, it's got whole Swiss cheesy, and So when that water comes through the cracks, and so if you've been in a cave, you see the stalactites and stalagmites, right? That's the calcium carbonate that dissolved in the limestone, and then it drips, the water evaporates, and it leaves that precipitate behind. So the sediments originate in the rocks, and then the lithification occurs, and we get compaction. I mean, the lithification occurs through compaction, cementation, and it forms it into a rock. We're going to look now at that type of rock. Can you tell me what type of rock I'm describing? A sedimentary rock. So now we're going to look at sedimentary rocks. But first, but wait, there's more. I want you to spend about 3 minutes reading and justifying your answer.